Last episode our run converged and wrote its results to disk. But a folder full of numbers isn't an answer yet. Today we turn it into one. ParaView looks overwhelming, hundreds of buttons. But you only need a mental model and a handful of tools. And the real goal isn't a pretty picture, it's a number you can put in a report. 2 ways in. The command ParaFoam launches ParaView pointed at your case. Or make an empty file ending in .foam and open it directly. The .foam trick is worth knowing. That little marker file is all ParaView needs to recognize and load the whole case, time steps and all. It works anywhere ParaView is installed. Here's the one idea that makes ParaView click. It's a pipeline. You start with your data, then chain filters each takes data in and produces new data out. Your case is the source. You attach a filter to it, then another filter to that, building a chain. At the end, a view renders the result on screen. Every ParaView tutorial you'll ever watch is just someone building one of these chains. Once you see the pipeline, the hundreds of buttons become a menu of filters to snap on. The simplest thing you can do is also one of the most useful: color the geometry by a field. Here's our cavity colored by velocity magnitude. Instantly you see where the fluid moves fastest, bright near the moving lid, still down in the corners. One click, and the flow field is legible. Switch the field to pressure, and you read the pressure map instead. Color by field is your first, fastest look at any result. Out of all ParaView's filters, 5 earn their place in almost every CFD post-process. Each answers a specific question. Glyph places little arrows across the field, so you see direction at a glance, not just how fast, but which way. Stream Tracer draws streamlines, the paths fluid parcels follow. This is where a flow tells its story: recirculation, separation, vortices. Slice cuts a flat plane through a 3-dimensional result so you can see the interior, not just the outer surface. Contour draws ISO surfaces, surfaces of constant value. Great for shock fronts, or a single pressure level. And clip or threshold hides everything except the region you care about: a wake, a hotspot, one part. Now the part that separates an engineer from a hobbyist. Pretty pictures are nice, but you need numbers. Here's how you pull hard data out of a simulation. The best one runs while you solve functionObjects. Add a forces or forceCoF subject to control dict and OpenFOAM computes drag and lift every step, no post-processing needed. Your report numbers write themselves. In ParaView, plot over line samples a field along any line you draw and gives you a proper graph, a velocity profile across a channel, say. And integrate variables: totals a quantity over a surface, the mass flow through an outlet, the average pressure on a wall. Real, reportable engineering numbers. And that's the complete workflow. You can now mesh, set boundary conditions, choose schemes and solvers, run and monitor, and extract real numbers from the result. That's phase 1, the entire practical loop of OpenFOAM. So far you can use OpenFOAM. But we've treated the solver itself as a black box, and this series doesn't allow black boxes. Phase 2 cracks it open. Next episode, how SimpleFOAM actually works, the algorithm that solves steady incompressible flow. This is where it gets deep. See you there. Last episode